Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation. Once again, trying to provide you as much insight as I can at these finalizing pieces of this proof and of this derivation, because it's hard to access the intuition and it's directly based off of the language that's being currently derived and worked on. And so I don't think anything I've said is empirically wrong, but I'm showing you all of the intuitive, because truly at this point where I like the logical physical boundary. And so just providing you, talking you through any things I know, don't know, and things that can be known. But last time we talked a lot about improving, I put it in green letters, I mean the colors don't matter that much, but I'm trying to show you the feeling of intensity of proof, meaning like this is a good big result at my level or development. It takes a while for like something to be like, wow, this is new, but I like to try to point that out. So ultimately trying to stabilize sensorality, but now we're really going to talk about what is physical stability. Keep saying vibration stabilized into energy, energy stabilized into mass. The words are logically consistent, but we're going to try to provide either more physical insight or consider out loud why we can't have more physical insight. Because what we're demonstrating is we've categorized our environment. This fundamental stability of 2 is the overarching major thing. But what is charge to mass? And so the only thing we really have is mass, and then we've deduced things, right? We have this fundamental stability of 2. We live in n+1 dimensions, that's 3, but the third is a phase change. It hasn't stabilized. And so all of our physical systems have a numeric limit of 2 dimensional components or 2 properties, 2 things required to completely describe their existence. And so, right, I say, so again, vibration and energy, those are 2 things no one's directly interacted with. I mean, they're deductions, they're logical inferences. Things that are in the past are set, they're fixed, they're invariable. And so last episode we also talked about variability, and then things that are set are not variable, things that can't change are variable, right? The past is invariable, the future is variable. And so I want to try to talk about these what these phase changes mean physically. And so I'm going to challenge myself again when I keep saying the universe was either hot and dense. We'll get to that here in a second. But what is charge to mass? And so vibration stabilized into energy, energy stabilized into mass. Mass is related to energy, that's an inference. Mass is related to vibration, that's an inference. But it's logically complete, right? The empirical evidence, people saying good vibes, people saying, not even really rhythm. We're talking about vibration. But how would that stabilize, right? Vibration is described by frequency, a cycle that does not do work. And so the big kind of conceptual thing that's impossible to not conceptualize is systems without mass. And so in R1 and R2, when you have one system with one dimensional component, and that's the whole universe, and then the whole universe evolves by differentiating, right? You have one thing represented by ing, that's vibration, and then it differentiates. And that differentiation has to stabilize. And so that was when we went through that again, I didn't watch the episode, but I felt very confident in explaining why, right? We got to the why, we answered why the universe started with very, very low entropy. You have something, it differentiates. When all you have is one thing, it just has to be not that thing. And so that's where you get our stability of 2. But physically, what does that mean? Vibration is described by frequency, a cycle. So what is cycling when there's no discrete mass? Doesn't really make sense. Again, that's our physical intuitive bound. There was no intuition present from anybody, anywhere, ever, or never will be to explain what that really means. But it's true, it's evident, and it's preserved within our words. That's why we say good vibes. And we covered last time how you can't actually have no temperature, and you can't actually so everything's always vibrating. But it's the mass, it's the physical mass that is vibrating. And so then vibration, you have one thing, that's vibration, it differentiates, right? Then you have energy. Energy is by definition, and these aren't my definitions, these are the words are naturally defined. The potential to do work. And so that really becomes, again, tension, this discrepancy, systems with mass removed from equilibrium, tending back towards equilibrium. So that's really what potential energy is. But then people say kinetic energy. But kinetic energy is really encapsulated by rhythm regulating movement, cycles that do work. And so keep rehitting those things. But what does it mean, again, physically? So now, vibration stabilizes into energy, energy stabilizes into mass. But if you don't, again, the potential for movement without something to move through, right? Movement comes from a change of distance over a given amount of time. That is what movement is. And so when you have two-dimensional components, vibration, not vibration, which is energy, right? Do you have the capacity for movement yet? Still no, right? So this is our universal phase change where now energy is the capacity for movement, but that's inferred in an environment with mass where you can clearly move. But that's when we get our conservation laws. For every action, there's an equal and opposite reaction. Force is reciprocal, charge is conserved, and mass is conserved. And so what is, right, I have a notebook here. This is a stable system. The electrons are bonded. The electrons are not flowing as a sea, so it is not currently conducting electricity. But this thing is made of charged particles. And they're just in a configuration where that charge is neutralized by the opposing charge. We covered last time, again, the biggest thing empirically as to why charge is definite, charge is discrete, charge is a property of mass, is that the proton is much larger than the electron, but both have 1 unit of charge. And then, again, the intuition felt very good yet before, again, saying between a magnet and charge is that the magnet has to be the stabilized dynamic. But again, when we say charge, I'm sure you're thinking positive or negative. But those are adjectives, right? When we say charged particles, and they're positive or negative, you just have some fundamental difference. We've labeled that that's charge, that's true, but all of, again, the immediate verbiage people use is, again, charged particles. But the particles, again, is there a logical difference between saying charged particles and particles contain charge? So now charge is a word that I like less than chirality. I think we've used that one properly now. But again, the shape, when I hear chirality, just think helix. The reason your genome or your DNA's base pairs line up the way they do is because of chirality. And so how does energy, vibration stabilizing into energy, energy stabilizing into mass, again, when I look at my notebook right here, this thing right here that's discrete, it can move independent of me, I can put it on a scale, it has weight. Is the actual mass charged? But what is that? Because charge would be polarity, right? That would be, what is stabilized? What is this thing right in front of me made of? This is mass. It has positive and negative components. Those components are in a dynamic that doesn't have the electrons move to outside of the system, and they don't even really move within the system. And so the point being is, how do you have frequency? Again, that describes vibration. You don't really have frequency until you have periodicity. But when you have vibration or energy, what is periodic? Again, and I'm just showing you there's no other questions to ask. This is the logical physical boundary. These words just contain the meanings. The completeness is emergent from these fundamental components: vibration, rhythm, energy. But tension charges, right? If you're in a tense situation, it's very emotionally charged. So we're just trying to, again, emotion is the range of motion. So we're just trying to find, in the same way you have fractions, which are parts or comparisons of systems, words, like some of them are fractions of complete words, and we're just trying to line them up to get sensorality, but more to have a complete description of the world around us, which we already do. Again, I've already done this step, I'm just talking you through it. And the intuition, again, it's not fleeting, but it's when you derive every single day, all day, every day of your life, like I said, the things that you can talk most poignantly on are the things that you're currently deriving. And again, I'm the one building all of the logic. If any person were to come up off the street, again, it's right back to, I can predict literally every single word out of your mouth faster than you can produce it. That's not a joke or an exaggeration. But we're trying to find, again, to expand our understanding of charge, again, we look at discharge, right? We can say, a firearm is discharged, but just other context where you use these words with prefix and suffix in a way that's more well-defined. Can give you some more insight. Nothing really comes to mind, but sensorality discharges. And so I just keep, again, physically, when I look at this notebook, or when I look at myself, and I say, this is stabilized energy. Energy is a cycle that energy is the potential to do work. What is the potential to do work? Work requires movement. So, again, energy and vibration are inferred. Again, that's a huge logical proof, but again, it's not as satisfying as other things because there's nothing else to say. But again, are particles charged, right? Particle is just a word for mass. Can you differentiate mass from charge? Can you separate the two things? Can you have something that weighs something but does not have electrical distribution? No. And so I keep trying to conceptualize or provide more words to what this physical stability actually is. But that's what I'm saying when words are irreducible. Words have meaning, they can't be broken down. How does stabilization relate to differentiation? So chronologically, something existed. Well, nothing. Again, I had to tell a story about the early universe. But again, everyone existed in a world where something, and then the inverse, opposition doesn't exist universally, but the inverse of the universe is nothing. And yeah, covered that plenty fine. But you have one thing. That's where we're starting, is thing, and that thing had to be not that thing. It had to differentiate. That differentiation had to stabilize, positive and negative. And that dynamic, they're moving. And I just want to say that mass is, the property of mass is charge. And I think we see that again by charged particle. All right, you're putting an adjective in front of particle. But to me, it's just saying like an inanimate object, right? Objects, the word object is already containing the intuition of not being sentient. And so that's what I think's going on there. I just don't think you can break down charge anymore. We've showed charge to range. But yeah, you have to have differentiation, and then you're stabilizing that difference, right? And so then in R3, we had the recombination period. So this is where I'm back to, at the beginning, I kind of said, the universe started in a hot and dense. What is very clear, undeniably empirical, extremely low entropy, and things are getting cooler down. There's a lot more space out there, and space is cold. And so things are getting cooler. Locality, you have differences, but everything else basically a little point and everything's getting colder because the temperature is the things bumping into one another. And so the stabilization is physically limiting entropy. And so disorder into energy, again, is entropy. And so but what is entropic? What is the inability to do work when you don't have mass? Is like you can't have movement, so nothing can do work. So it's kind of, again, it's this natural universal progression thing. But you differentiate, then you stabilize by limiting that difference. And so in R3, right, we had the recombination period. And so to me, I'm just trying to think intuitively, did the mass spread out, or there was just this big vibration thing with no concept of space, and then it condensed and it stabilized? And again, that's why E equals mc squared. You take 1 grain of sand, it has a tremendous amount of energy. And so again, it's just energy. I kind of want to say the F word here, field, when I just said it doesn't apply to physics, but I'm trying to use intuition, because then obviously you don't have a field. Means, again, a bunch of discrete objects moving kind of together, and you lose that coarse grain. You just see the overall object. But you kind of have a field of vibration. Well, and that's already aids intuitively. But that aid, and then it stabilizes, which to me makes the most sense. But then how did the things get away from each other? And again, that's just where the intuition to me breaks down. And not like it doesn't make sense, as there's nothing available to say or to do, because all measurements have occurred with mass. All of our instruments are some interaction of mass. And so that's what I want to say again for the stabilization. And then that stability produces, again, periodicity. Two things orbiting each other, and they stabilize. It produces internal spin. And so, But I just wanted to know, again, what is charge, and then you say electrical charge, which to me means, again, what is charge? And personally, intuitively, I cannot remove the concept of electricity from the concept of charge, which again, I think that's what it is. But again, trying to talk to you, anything that comes to mind. But moving on, the H in math is the same as the H in physics. And again, you can kind of hear it, math, physics. And so physics is literally ix. And you even kind of get some internal reflection. In reflection, kind of like when you have this mirror symmetry over a line, physics, right, is is. Obviously, it's represented by hy here, but then you get si. So again, ili from infinitesimality. There's some reflexive thing going on there. But does frequency have polarity? And again, you can't have frequency until something is cycling, right? You need cyclicity to have a period. But so again, trying to get more on these phase changes, right? Polarity, charge is polar, right? They're polar opposites, positive, negative. Or again, what is the magnetic poles called? Again, just positive and negative. And so that's why I'm thinking it's stabilized charge, but then how could it be anything else? But what am I missing? I'm still, again, and on a personal level, again, I cannot resolve this feeling of incompleteness. The physical time just has to pass because, again, all of these steps the logic is already contained within the words. But can you have polarity to frequency? Something goes around in a circle. That's 1 period, 2 period, 3 period. Its frequency is every 10 seconds it goes around. Does that have polarity to it? What is the relationship of polarity and frequency? Vibration produces frequency. Mass vibrating produces frequency. Mass produces math. It's another huge physical, logical connection. Obviously, mass and math are different by two letters. Polarity is tension, right? Opposition is polar. And so now very clearly, intuitively, like I said a million times, tension is the thing that replaces potential energy. You can't have a one-to-one replacement because all of your inconsistencies in theory is why you need to restart everything, which luckily for you guys, I've done the whole thing now almost twice publicly. But point being, tension. How does tension relate to energy, right? Tension depletes energy. If you're sitting there straining, trying to push something and you can't move it, you deplete your energy. If you're in a really tense emotional situation, it depletes your energy. So tension is inversely proportional to energy. So tension is proportional to entropy. And so, right, because tension, right, that's a word that contains internal discrepancy. And so energy is tensious. Yeah, because you can't have tension unless you have some sort of removal from equilibrium. And so mass produces math, polarity is tension, opposition is polar. Again, we made that huge logical difference. Inversion, there's no opposite of mass. Nothing is not the opposite of mass, just less mass. It's a limit. And so, but within this bounding, you have this fundamental stability of 2, and then we have this open dynamic, and because of that fundamental stability of 2, we have natural opposition. But opposition is polar, right? You have the term polar opposites. Sensorality is celerity. And now again, sensorality, now we uniterate celerity and sorality. Sorality is celerity. You just switch the R and the L. You iterate them. Celerity is censorious. Sensorality is oriosity. Sensorality is obvious. Sensorality is obviosity. And so now, like curious and curiosity, you go from an OU just to an O. That's another one of these spellings where, again, when I'm going through these words, and you can see some of these simple, again, you can see some of these words where, again, out of all of this stuff, I still don't know what spelling is. But there's a right way to do it, and it's just like we're all trying to figure out kind of what's going on there, or at least I am. But point being is you go from an OU to an O, and that's another one of these things that is not clear. as to when that happens, why that happens. In the same way, something that ends with a C, and you want to, calorically, I don't know, first thing that came to mind, calorie, it's like a calorie, it's calorically. But do you put an LY, is it LLY? We've pointed that out. But it's O to O, or OU to O, curious to curiosity. It's one of those what's why, but it definitely pops out. But viscosity is resistance. What is the relationship between difference and resistance? All right, difference produces resistance. Difference is differentiation. Sensorality is differentiality. Sensorality is inferential. Inference is essential. Essentiality infers. Magnets are sensors. So now again, everything is effectively a magnet with stabilized dynamic of charge internally. That's what everything is. And so, right, fundamentally again, this difference between sensorality with a C and sensorality with an S, magnets are sensors. Sensors with a C. Sensorality is sensorium. Sensorality is sensorum. Sensorality is decorum. Sensorality is decorality. So now again, start looking at the S's in sensorality as just iteration placeholders. And we're just cycling through these letters until we get them in the right, and we can show this direct iteration to stabilize sensorality. So then again, linguistically, stability is, we're just trying to talk about physical stability, is showing this undeniable connection of linguistic representation, letters, to a physical process. Sensorality decorates, right? And then we take off the DE, functioning as a prefix. Decorality, sensorality is chorality. But now, again, we have sorality, S-O-R, and then chorality, C-O-R, ality. To corral is to censor, right? Corralling corners. Censoring corrals. Censoring is chorality, like corralling I went to our high school with the Stallions. The Stallion Corral was our student section at the gym, right? Sensorality corrals, censorship corrals. So trying to provide you, again, I literally sit down and want to say more about these phase changes, but you literally physically can't. So I'm just taking you up to this physical logical boundary. We are well more generalized past what is structured mathematics, all being completely logically consistent, showing you exactly. And again, if there's something that fills in this blank, it just doesn't matter. I don't say it doesn't matter, but again, to stabilize sensorality, we already proven like 100 episodes ago, the solution's out there, so on and so forth. But we're demonstrating the irreducibility of word. And so that's what I wanted to say is, again, we clearly have sets. We have sets that are set that won't change in the past. One thing, two things, many. And so that one thing was vibration, but what was vibrating? What was cycling? And how do you cycle without physical thing? Like that's the whole point, is you can't answer these questions. There's no intuition, there's no conceptualization that exists. And then you have two things, right? And then energy, right? Then you have, again, frequency, and then people say light has momentum, but just the entire, all thing, and again, thing doesn't, the ing part existed, but not the th part. And so you go from ing to, I don't know, ting. Again, there's no linguistic representation. All language is after these physical stability phase changes. And so, but just trying to pair, again, the unique pairing of physical systems to mathematics to numbers. And again, I've already done this whole process. I'm just trying to show you the steps as they come to me. But like I said, this is the performance aspect. There's no point. I don't say there's not no. I don't want to be doing this. There's no point that I should have to do this, and I don't have to do this. But this is what I'm saying: profound and extensive torture. I cannot turn off synesthesia. Like I can't like turn it off. And so you deprive me of my rights, and you create this intense internal conflict. And it's effectively caused by not knowing 1 + 1 = 2, but I've already personally proven 1 + 1 = 2. But when you have such a sensitivity to logic and to language, you literally have to very literally prove every single logical statement you encounter, which actually isn't difficult when it's dealing with somebody else, because it's like, again, they're still on like 1 + 1 = 2, and 1 + 2 might equal 3, and it's like, I definitely know 1 + 2 = 3, but I have to build this entire context. again, showing speciality was conceptually the same thing as infinite uniqueness, was, I don't want to say easier, and like I said, it's time dependent, but there was something to solve. And so since speciality is special with an ITY, the entirety of everything is self-built, contained logical structure. So we'd already solved all of science, and the only thing to do again is to rederive everything. Which we were very close. We were almost done somehow, but again, it's just a very clear physical progression. Trying to walk you up, demonstrating the irreducibility of words, trying to provide you as much physical intuition as I possibly can. Again, look around you and say, okay, that thing has mass. What is that mass? And it's stabilized charge. And so then you could say, well, what is the charge? And then that is where I just think it's physical irreducibility. I'd be happy to be proven wrong. Or again, I could literally just look up and see what I talked about last time. But there'll be way more. Again, there's no value. This is just a performance. This is a performance where it's like you started the concert where people weren't sure if the guitar was real. And now you're playing Beethoven's symphony backwards with your eyes closed upside down. And if you miss if you play 10,000 notes and hit 999 of them, it doesn't really matter if you get one or two right or wrong. And so, but on a personal level, like I said, the intuition will resolve. That's just a literal physical limit, a matter of time passing. But on a personal level, it's torture. Like, I cannot speed this process up, and it creates this internal conflict because I have such a sensitivity to language. And when you're so far down the rabbit hole, so to speak, or so involved in one of these mathematical proofs, you can't like turn it off. And so that's what I have for you tonight. It's been a productive day. It's always a productive day. Thank you for watching. See you on the next one.